You're welcome, our dear students of the first year of preparatory school, preparatory stage, in your program مدرسة على الهواء. It's very honor to me to explain your curriculum in science. Today we're going to talk about the first lesson. First lesson talks about matter and its construction. Now, it's a question for you. Is this matter? Yes, it's matter. Why? Because it has mass. I can put it on the scale and take the reading of a scale because it has mass. Number two, it has volume. It takes place. It occupies a space. Is air matter? Yes, air is matter because it has mass. If I have two balls, first one is empty ball and second is full ball, and I put them on the two-band balance, okay, which one is heavier? Sure, the full ball is heavier than the empty ball. Why? Because air is matter, because it has mass, and air takes place inside the ball because air has volume. Water or any liquid is matter because it has mass and it has volume. So let's start now, as you see on the monitor, about the title of our lesson today, matter and its construction. But first we have to know what is meant by matter. Matter, it is anything that has mass and volume. But first we have to explain what is meant by mass. If I have a very big book, it has maybe 500 paper, and another book which has 200 paper, which one is heavier? Sure, the book whose paper are 500 because it has more amount of paper. So what is meant by mass? It is amount of matter in an object. What is meant by the mass of a golden ring is 5 grams. Golden mass of golden ring is 5 grams. It means the amount of gold, amount of matter here, amount of gold in the ring is 5 grams. What's meant by the mass of a wooden door is 25 kilograms. It means the amount of wood in the door is 25 kilograms. So what's meant by mass? As you see on the monitor, mass, it is the amount of matter that the object contains. Okay. Now, what's meant by volume? Volume is the space that is occupied by matter. Volume is the space that is occupied by matter, or it is the space that the object occupies. If I have a taxi, the taxi can take just only 4 people. It can't have more than 4 people because this is only the space, this is only the place that you can occupy. So each matter can take just a specified volume. So now what's meant by volume, as you see on the monitor, it is the space that is occupied by matter. But as you know, my dear students, we can differentiate between any two substances by some of their properties, because each matter, each substance has its own properties. If you are a girl and your mother asked you to go to the kitchen to bring some sugar, okay, and you can see 2 pots, one of them its color is white and the other is white, how can you know which one is sugar and which one is salt? Can you? Okay, let's see now. They are 2, and I can put each one in this saucer, okay, and this one on the saucer. They have the same color. Let's try smell. I can differentiate between them by smelling. So I think I have to taste some of them. It's tasty. It's sugar. But this is not sugar. Salty. So some substances, we can differentiate between them by using taste. So, first, we have to talk now about what? About the physical properties of matter. We have two types of properties, physical properties and chemical properties. What's the difference between them? Physical properties related to the melting point, boiling point, color, taste, smell, and so on. But chemical properties means the chemical reaction. Today we're going to talk about some of physical properties. Physical properties. Number one, how can I differentiate between salt and sugar? Yes, they have the same color. By what? Yes, very good. By taste. Number one, taste. I can taste anything, but not anything, because some substances are very dangerous. We can taste, maybe poisonous. But some substances, we can differentiate between them by taste. And others, what is this? Can I say this is a golden ring? It's not golden. Its color is not golden, but its color is, yes, silver. So it can't be gold, but it may be silver. Why? Because I can differentiate between gold and silver by using color. So now let's talk about physical properties of matter. First, one is color, taste, and smell. I can differentiate, I can use color to differentiate between what? Yes, as you said, between gold and, we can differentiate between silver and gold by using what? By using color. Yes. And now we talked about color. Let's talk about another property. We can differentiate between sugar and salt by taste. Yes. We can differentiate between vinegar and perfume by smell. I can't taste the perfume, and I can't recognize, I can't know that this is perfume from its taste or from its color, but just I have to smell. And now, be careful during smelling anything. Not all substances you can smell, because some of them are very poisonous. But we can here differentiate between vinegar and perfume by using smelling. If someone gave me two bottles and he asked me which one of them is perfume and which one of them is vinegar, just here I can smell, because I am sure that one of them is vinegar, that another one is perfume, and now it's not dangerous to smell. So now let's revise. The first physical property of matter is what? Yes, is color, taste, and smell. We can differentiate between some substances by using color as gold and silver. We can use taste to differentiate between another substances. We can also differentiate between some substances just by smell, color, and taste. Second one, water and oxygen have no color. I can't know the water from its color because it doesn't have color. It's colorless. Colorless means it has no color. Oxygen, it is colorless, as you studied in primary 6. It has no color, it's colorless. But sure, there are another properties that we can differentiate between them. But we can't differentiate between them by taste, because we can't taste oxygen from air. We can't use color because they are colorless. And we can't use smell. But sure, there are other properties that we can differentiate between oxygen and water. Okay. This is the first property. Let's talk about the second property, density. What is meant by density? My dear student, you can ask yourself why if we want to put some or a piece of wood on the water, what happens? It floats on the water. It floats. But if we put just small or big piece of iron on water, it sinks. Did you ask yourself why? Due to the density. But now, what's meant by density? If I have a cube, just cube, this cube has volume. Its volume is 1 cubic centimeter. Its length is 1 centimeter. Its width is 1 centimeter. Its height is 1 centimeter. So its volume is 1 cubic centimeter. If I have two cubes now, first one is from wood and the second one is from gold or maybe iron. Okay? And I hold the first one and I hold with the other hand the second one. Which one is heavier? They have the same volume, 1 cubic centimeter. But which one is heavier? Sure iron. Sure iron. Why? Because density of iron is more than density of wood. Because particles, molecules, small parts of iron are close together. But in wood, no. A lot of iron, more amount of iron, are collected in just a small volume. So they are collected, they are heavy. So here, iron has density more than wood. So iron is heavier than wood. Which has more volume? More volume. If I have 1 kilogram of iron and 1 kilogram of cotton, which one is heavier? Not iron is heavier than the cotton because they have the same mass, 1 kilogram. I told 1 kilogram, I said to you that 1 kilogram of iron, 1 kilogram of cotton. When I put them on the scale, on the two band balance scale, okay, they are the same. But which one takes more place, more volume? Yes, cotton. Why? Because mass of iron is more than the same volume of cotton. Why? Because each substance has its own density. We have no two substances have the same density. If they have the same masses, must be volume, different volume. Sure. Because each substance has its own density. Now, I have a question for you. Which one of them has more density? A small piece of iron or a big piece of iron? I could hear some of you say the big piece. No. They have the same density. Because density is physical property related to just the material, the type of material. Iron has the same density. If it is small piece, if it is very big piece, if it is a piece as your room in volume, it doesn't matter. It has just own density. What is meant now by density? It is the mass of 1 cubic centimeter of matter. If I have a cube, its length is 1 centimeter, its width is 1 centimeter, its height is 1 centimeter, so its volume is 1 cubic centimeter, so its mass is what? Its mass is 7.8 gram. If it is iron, 1 cubic centimeter of iron, its mass is 7.8 gram. If I have 2 cubic centimeter of iron, has more mass, has more volume. Sure, its mass is bigger. Its mass is double. So, if 1 cubic centimeter of iron has 7.8 gram, 2 cubic centimeter of iron has what? Yes, 15.6 gram. 10 cubic centimeter of iron has 78 gram. 20 cubic centimeter of iron has 156 gram. Yes, by increasing volume of the same matter, its mass increases. By increasing mass of the same substance, its volume increase. So, if I divided mass over volume, this ratio is constant. Constant. It's called density. So, what's meant by density, as you see on the monitor, density is what? It is the mass of a unit volume. That means I have to get 1 cubic centimeter of this matter and take its mass. This mass equal here what? Equal the density. What's meant by the density of iron is 7.8 gram per cubic centimeter. It means that each 1 cubic centimeter of iron, its mass is 7.8 gram. Okay, 2 cubic centimeter of iron, its mass is 15.6 gram. As you see on the monitor, density is physical property that depends on a type of material only and temperature. But here we concerns about the type of material. It doesn't matter its mass, it doesn't matter its volume, because when we divide mass over volume, we get the same answer. It's density. Okay? Water has constant density. It doesn't change. 1 gram per cubic centimeter. That means if I have 1 liter of water, 1 liter of water, and I put it on the scale reading will be what? 1 kilogram. If I have 1 milliliter of water and put it on the scale, its mass, it will be just 1 gram. So each 1 cubic centimeter of water, its mass is 1 gram. 2 cubic centimeter, yes, 2 gram. 3 cubic centimeter, 3 gram. So what's meant here by density, it is the mass of just 1 cubic centimeter or a unit volume. Water has constant density. Its density is 1 gram per cubic centimeter. Iron has constant density. That is 7.8 gram per cubic centimeter. Cowork, Filin, that can float on water, has constant density 0.25 gram per cubic centimeter. Copper, 8.8 gram per cubic centimeter. Now, what is density? Density equal mass over volume. Mass over volume. Now, let's learn one important thing now. Density equal what? Mass over volume. Okay? Mass over volume. Now, I want to make triangle to be easy to answer any question here in science. In this equation, this is called physical equation. D is for density, M is for mass, V is for volume. Okay? What I can put here? This is dividing. So I can put this physical quantity, mass, up, and the other two in these places. Okay, so if I want to get mass, I have to multiply density by volume. Mass equal density by volume. If I want to get density, it's mass over volume. And if I want to get volume, volume equal mass over density. This triangle is very important for any student who studies science. You must know, you should to know how can you make this triangle to solve any problem. Now, let's talk about some question related to density. Number one, what happens if mass of a substance increases to its double? Mass increased to its double. concerning density. He asks about what's happened for density. Now, density equal mass over volume. What happens if mass increases? Can you say that density increases to double? Sure, no. Why? Because density is constant for each substance. For water, 1 gram per cubic centimeter. For iron, 7.8 gram for each cubic centimeter. So it doesn't change. It's constant. So what happens if mass increases to double? It means that volume increased to double. So we get the same constant. If mass increased to 3 times, volume increases to 3 times. So we get the same ratio. Okay? Now, this question is what happens if mass of substance increases to its double concerning density? Nothing for density. Density remains constant while volume increases to its double. Okay? Another question. Give reason for. Iron sinks in water while wood floats. If I have a piece of iron and another piece of wood and I put them on water, what happened? What can you notice? Yes, iron sinks while wood floats. Why? Give reason. Sure, wood is lighter, less heavy. It's not heavier than water. It's lighter than water, so it floats. Water can carry wood, while iron is heavier than water. Density of iron is more than density of water. It's 7.8 gram for each cubic centimeter, while wood is less than 1. So how can we answer this question? I can say because density of iron is more than density of water, while density of wood is less than density of water. Number 2, balloons are filled with helium because density of helium is less than density of air. Okay? Now, thank you, my dear students, for your good watching. Hoping to meet you next week. I'm promising that we will meet on this time next week. I can leave you and you can join with our official page on Facebook, الجروب الرسمي مدرسة على الهواء. Thank you and see you next time.